This meeting is being recorded.
Hello everyone. I request everyone to please mute their mics. I request everyone to please mute their mics. Hello everyone.
माझा माईक ऑन आहे का नाही मला माहित.
Okay. Is it my voice is audible? Is my voice is audible? Can anyone tell me?
Yes,
Either in
Mayur.
chat. Okay. So hello everyone. Myself Mayur Kate. I am the alumni of VPKBIT Baramati 2019 batch. Currently, I am pursuing masters in CVP College of Engineering Pune in field power electronics and machine drive. So today's topic is this session is for GATE exam preparation, which is sponsored by AICT under Prerna Center for SCST student, and the center is at VPKBIT Baramati. Okay. Now today's session is okay. Now today's session is under today's session we will see on topic on control system. Control system is very excited topic, or we will say very interesting topic for GATE exam for people who are preparing GATE exam. Why? Why? Because it is a very important or exciting topic, I will say. Because most of the questions from control system are direct. Most of the questions from control system are direct. What do you mean by direct? It means that they will directly say find this, or they will not trick the question. They will not play with the question. They will directly give you the question, and you have by seeing or by reading that question, you will get what to find or what has not to find. Okay. Now I will not go with the basics of control system, but just give a small description. What do you mean by transfer function? What do you mean by transfer function? Transfer function is defined as output in Laplace domain. Laplace domain. I hope everyone know about what is Laplace domain in terms of S by input in Laplace domain. What do you mean by transfer function? Transfer function is known as output by input. Okay, so there are two types of control system. Open loop. There are two types of transfer function, we will say. One is open loop transfer function and another is closed loop transfer function. So what do you mean by open loop transfer function and closed loop transfer function? Let's say there is a system which is G of S. What do you mean by G of S? It is gain of a system, and here is one input. We will call it as C of S. We will call it as C of S, and there is one upon another output which is called as, let's say, y of s. So there is no feedback system, so it is called as open loop transfer function. So what do you mean by this is open loop transfer function? Open loop system. This is open loop system. Another is closed loop system. Closed system will be like g of s. There will be one y of s. Here we will one summation box. Here will be one feedback system h of s. Why I am writing this in bracket s? Because it is in Laplace domain. So all the calculations in transfer function, all the calculations control system are usually done in a Laplace domain. Why? Why? Because Laplace domain is very convenient, very easy to handling, very easy calculations are in Laplace domain. That's why when you are dealing with a control system, usually you are dealing it is in Laplace domain. After calculating in Laplace domain, then you will convert this Laplace domain to time domain, and time domain is actual domain. What do you mean by actual domain? Is real world domain. Okay. From here we will get C of S. Okay. H of S, Y of S. This will be the output. So what is the transfer function for open loop system? Transfer function for this will be transfer function of this will be output y of s divided by c of s, y of s divided by c of s, which is equal to g of s. Okay, and transfer function for this will be, let's say here, minus plus. Okay, transfer function for this will be g of s 1 plus g of s into h of s. Okay, so transfer function for closed loop system is given by g of s divided by 1 plus g of s h of s. Listen carefully. Whenever there is a negative feedback, there will be positive sign in denominator. Whenever there is a positive sign, then in denominator there will be negative. So this is most important point. Transfer function for open loop system is given by g of s. Transfer function for closed loop system is given by g of s divided by 1 plus or minus g of s. So when to take plus, when to take minus, I have explained. When there is negative feedback, take plus. When there is a positive feedback, take minus. Okay. Now watch carefully this equation. Carefully watch this equation. Okay. This denominator part is called characteristic equation. Characteristic equation. What do you mean by characteristic equation? Which is equal to 1 plus g of s into h of s. 1 plus g of s into h of s. So what is characteristic equation? 1 plus minus. Whenever they call positive feedback, take negative. When they call negative feedback, take positive. So what do you, this denominator portion, 1 plus or minus g of s, h of s, is called characteristic equation. So characteristic equation, by doing some mathematical calculation on characteristic equation, or by studying characteristic equation of a transfer function, characteristics of a transfer function, we can say whether a system is in stable form or unstable form. Whether a system is in stable form or unstable form. Okay.
Sorry,
Now let's
can
say,
you repeat once?
From which part can you say? From which part I have to repeat? Or the whole thing I should repeat?
Yes, sir. Whole thing.
Okay, listen. Above diagram is for open loop system. The below diagram is for closed loop system. What do you mean by open loop system? There is no feedback. There is no feedback for system. And what do you mean by closed loop system? There is a feedback. So transfer function for open loop system is given by output by input, which is equal to y of s divided by c of s, which is equal to g of s. Okay, and for transfer function for closed loop is given by g of s divided by 1 plus or minus g of s into h of s. Okay, one more thing I have to add is that when to use plus and when to use minus. So whenever they say there is a negative feedback, use plus sign in denominator. Whenever they say there is a positive feedback, use negative. Okay, and the denominator part, denominator, closed loop transfer function, closed loop transfer function, denominator part is called as characteristic equation. Closed loop transfer function, denominator part is called characteristic equation. So what do you mean by characteristic equation is that, or where is the help of characteristic equation, is that by studying characteristic equation one can find whether the system is stable or unstable. By studying characteristic equation one can find whether a system is stable or unstable. Okay, so this is the most important point. What do you mean by characteristic? Many of the questions were asked on this part, characteristics. It's not like we find characteristic equation, but in addition to that, tell whether the system is in stable condition or whether the system is in unstable condition. Okay. So please note down this point. I will tell few more theory parts. Then I will go for. Okay, listen. Now there is a conversion. Now there is a conversion. See everybody. See everyone. See, this part is for open loop transfer function. This is formula for open loop transformation, and below one formula for closed loop transfer function. So you can see there is a bit of difference. There is a bit of difference. What is the difference? In open loop transfer function, there is no feedback. That's why in open loop transfer function there is not h of s term. Okay, you can see that in open loop transfer function there is not any h of s term. Because why there is not h of s term? Because there is no feedback in open loop system. But in closed loop system there is a term which is called as term is given by h of s. This is because there is a feedback part. Okay, whenever, listen carefully, whenever they say unity feedback, always questions are like unity feedback, positive unity feedback or negative unity feedback. Whenever they say unity feedback, so what does this word means? It means that h of s is always equal to 1. Whenever they say unity feedback, it means that h of s is always equal to 1. So so always in gate exam, usually in 90% of chances in gate exam, they always say unity feedback. Before unity feedback they will add positive or negative, but one thing is always common is that is what? Unity feedback. What do you mean by unity feedback? H of s is equal to 1. So by by this point we can modify this formula. By this point we can modify this formula, which is equal to which is equal to closed loop transfer function, closed loop CLTF, closed loop CLTF. What do you mean by CLTF? Closed loop transfer function. OLTF, what do you mean by OLTF? Open loop transfer function. Okay, so by taking this point in consideration, closed loop transfer function can be written as g of s whole divided by plus or minus g of s. I'm putting h of s is equal to 1. I'm putting h of s is equal to 1. So instead of writing 1, I will simply neglect that part. Okay, instead of writing 1, I will just simply say g of s. Okay, now, now, now see, compare open loop transfer function and closed loop transfer function. Open loop transfer function. Compare open loop transfer function and closed loop transfer function, you will say in denominator part there is g of s. In denominator part there is g of s. Let's say in closed loop transfer function, if I subtract denominator by g of s, if I subtract denominator by g of s in closed loop transfer function, 1 plus or minus g of s minus g of s. Let's say here is a plus. Let's say for instance, if there is a plus and I subtract g of s from denominator, what does we get? We get open loop transfer function. We get open loop transfer function. So at the end, what I want to say that if you if in question if in question they have given if in question they have given closed loop transfer function, if in question they have given a closed loop transfer function, so you can find open loop transfer function for that system. So you can find open loop transfer function for that system by open loop transfer function is equal to closed loop transfer function divided by 1 minus closed loop transfer function. Okay, closed loop transfer function. What do you mean by this formula? By using this formula, you can find open loop transfer function for the same system. Open loop transfer function for the same system. Okay. Open loop transfer function for the same system. This is one more important formula which may expect a question on this formula. Okay. Okay. Now one more, sensitivity of a system. Okay, I hope everyone written this. Sensitivity of a system. What do you mean by sensitivity of a system? Sensitivity means that if there is a small change, in output, which is sensed by a system, and send feedback part to the input, and according to that feedback, output changes is called sensitivity. According to that feedback, output changes is called sensitivity. So for open loop system, there is a sensitivity. For closed loop system, there is another sensitivity. Okay, but one thing you have to take note that in open loop system there is no feedback. In open loop system there is no feedback. So because there is no feedback, so the sensitivity of a system is always equal to 1. So sensitivity of a system is always equal to 1. So listen everybody. So sensitivity is always related to closed loop system. Sensitivity is always related to closed loop system. Why? Because there is a feedback path. This is G of S, Y of S, C of S, feedback path H of S. Okay. So there are under sensitivity is one thing is clear is that sensitivity is for closed loop. Sensitivity is for closed loop. Then under sensitivity there are sub two branches. What are two branches? The sensitivity depends on G of S. Sensitivity depends on H of S. So how is sensitivity depend on G of S and how is the sensitivity is depend on H of S? What does this mean? That if I change value of G of S, then how will output will vary? If I change only value of G of S, then how the value of Y of output will vary? Another point is goes like how output will vary if I change H of S, or if I change linearly H of S, if I change put some variations in H of S. So how the output will vary? So there are two formula. Sensitivity when G of S is vary, sensitivity when H of S is vary. Okay, so I will give you formula when G of S is vary. Sensitivity for G of S, which is given by S. For Y of S, I will write Y. Output side output. Output will change. How the output will change when I change in G. Okay. So the formula is goes like how will be the output vary? How will be the output vary when I change? Output stands for Y, and in G of S, system stands for G. So I write this formula. When there is a small change in G, how output will vary? The formula goes like 1 upon 1 plus G of G and H. One G of S and H of S. I'm not writing S terms plus. So please take that there is nothing different, but for simplification I'm just writing G and H part. It means that if I vary G, how the output will vary, how the sensitivity of a system varies. So there is one formula which is given by SYG is equal to 1 upon 1 plus GH. Same another formula, how output will vary, if I change a bit of variations in a feedback. How output will vary if I change a bit of variations in feedback. It is given by minus G of H whole divided by 1 plus G of H. So there are two formula. So there are two formulas. What are the formulas? When variation in G, when variation in H. Okay. So when to use this formula? When in question they say variation in G of S. When to use this formula? Variation in feedback, H of S. Feedback, H of S. Gain of a system, G of S is called gain of a system. H of S is called feedback. H of S is called as feedback. Okay. So when to use this formula and when to use formula? When they say there is a variation in gain, use this formula. When they say variation in feedback, use this formula. Okay. Now this is for basic. Some more formulas are there. Okay. Now some important questions. I hope everyone know how to find transfer function. But using Mason-Gain formula, you can also find a transfer function. So I will tell how to use Mason-Gain formula for finding transfer function for any system. For finding transfer function of any system. Okay. So what is formula for Mason-Gain formula? Mason-Gain formula is given by Mason-Gain formula. Mason-Gain formula is given by delta summation k is equal to 1 to n delta k m k. So what do you mean by delta? This below delta. What do you mean by this below delta? Delta is defined as 1 minus sum of loop gain. 1 minus sum of, I will give one question so you can get loop gain. Okay. Minus plus sum of gain product of two non-touching loop. Sum of gain product of two non-touching loop. Two non-touching loop. Similarly, if there is third term, then it will come as sum of gain of product of three non-touching loops. If there is four term, I will give an example. You will get how to solve this question. What do you mean by delta k? What do you mean by delta k? The value of delta, the value of delta, the value of delta, the value of delta for which loop, kth loop, for which not it not it for which it is not touching kth loop. Okay, for which it is not touching kth loop. Okay, then what do you mean by mk? mk, it is a forward path gain. Forward path gain. So don't confuse by this formula. This is very easy formula, but by looking this whole formula, what is the summation delta k and mk, you will find difficult. But when I take a question on this part, you will find it be a bit easy. So don't go by this formula just for understanding. Just for if they ask what is the formula for this, then you should know how to what is the formula for Mason gain formula. Okay. Now I will take and then now I will take one question on this so that you can get a confidence. So that you can get a confidence. Okay. Don't worry about this formula. You will say, "क्या sir, ये बहुत बड़ा formula है." So you can. I will give an example, so you'll understand what this formula actually means. Let's say any signal flow graph is given, which is given by this. There is one loop. There is another loop. There is one more loop. This is x1. This is x4. This is x3. Sorry, x2. This is x3. This is x3. And FBD. Gain for this is F, gain for this is B, gain for this is D, this is E, and this is C, this is A, this is A. Okay. So if in question they ask find transfer function, if the question they ask for find the transfer function x1 by x4, x1 by x4. Don't get panic. I will tell you how to find this. Okay. If in question they given this diagram and tell you to find the transfer function for this system, which is equal to x1 by x4. Sorry, x4 by x1. So output is x4. So you have to take output at point x4 divided by x1. So you have to take input at x1, and the whole part is called as system, and the gain of a system is called F, B, D, E, C. So how to solve this type of question? First write down forward path. First of all, write down how many forward paths are there. Okay. So check forward path. You have to go from x1 to x4. So see in figure how many forward paths from x1 to x4, not x4 to x1. Only check for the paths which are going from x1 to x4. So what are the paths? See, A, C, E to get at x4. So first forward path is A, C, E. First forward path is ACE. Now check there is another forward path or not. Yes, there is another forward path which is given by A, F, A and F. Please take care of one thing. please take care of one thing is that do not repeat forward paths. If you repeat forward path, then your transfer function formula then or your answer will get wrong. So please do not repeat forward path. Now go for loops. Loops. Now go for loops. How many loops? How many loops are there in? How many loops are there in the graph? Now check for first loop. And by look, when you look for the loop, please note it down. Okay. So loop 1, L1, I will say L1. Check for L1. Okay. I will go from X2, X4, X3, and then again X2. The first loop I will say gain. I will just write gain of a loop. F D B. F D B. First loop I will say F D B. Second loop I will say C B L2 C B. Third loop I will say E D L3 E D. And fourth loop there is one G. Sorry, please correct your figure. There is another loop is called G. So there is one more loop which is called given by G. There is one more loop which is given by G. So how many loops are there in a figure, in a flow? F, D, B, C, B, E, D, and one more loop is called G. So I have to write gains of all the loop. I have to write gains of all the loop. Now I have to check for non-touching loop. Non-touching loop. I have to check for non-touching loop. So what do you mean by non-touching loop? So you have to find loops in a graph signal flow graph. You have to find the loops which are not touching each other. So what are the loops? Say, listen, CB is one loop which is not touching to G. You can say that you are saying that CB is a loop which is not touching to Gth loop. So there are two non-touching loops. So what are the two non-touching loops? They are L1, sorry, CB. So what are the loops? CB is a loop. L2 means L2 is non-touching loop to whom L4. So write it down like this. So you can see that this loop is not touching this loop. So I have given this loop as L2 loop. So L2 loop is not touching to L4 loop. So write it down like this, which is equal to C, B, and G. Okay. So this is a gain for non-touching loop. So this is a gain for non-touching loop. So there are one non-touching loop. There are one non-touching loops. So these loops are not touching each other. That's why I written under this part. Okay. Now come to the formula. Yes.
सर फॉरवर्ड पाथ मध्ये AFG येऊ शकतो.
AFG नाही येणार. Okay. In forward path they will never come AFG. Why? Because okay, I will tell you another way. So you have to always go for one forward path. In that forward path, none of these points x2, x1, x3, x4 will repeat. Okay, which means that आपको एक ऐसा फॉरवर्ड पाथ चूज करना है जिसमें कोई भी एक जो पॉइंट है, जंक्शन पॉइंट जैसे x1, x2, x3 और x4, ये जो भी पॉइंट्स है ये रिपीट नहीं होने चाहिए. मतलब कैसे? जैसे कि अब देखो A, F, is there any point which are repeating? No. All points are coming once, only once. But in a path, one of my friends said, but in path A, F, G, listen carefully, which points are coming? X1, X2, X4, and then again X4. Okay, so that's why in forward path A, F, G will not came. Why not came? Why it will not came? Because one of these points are repeating. So this should not happen. That's why I have not written in forward path A, F, G. Because in G, in that part, which part? In that forward path, which part? A, F, G, X4 point is repeating. That's why I have not written in forward path. Okay, so you have to take care that none of this point should repeat twice in any of the single forward path. Okay, now let's come to the question. Now let's come to the question. So what does delta means? So what does, first of all, find delta. So delta, what does I give for delta? What formula I give for delta is 1 minus sum of all the loop gains. First of all, 1 minus sum of all the loop gains. So here are the loops, and you have to take the sum of these all loops. Here are the loops, and you have to take sum of all the loops. So FDB plus CB plus ED plus G. So you have to write FDB plus CB plus ED plus G. Okay. So you have to take care for just go back and see the formula for delta. What formula I give for delta is that 1 minus sum of all the loop gains. So here are all the loops. Here are all the loops. These are repeated loops. These are repeated loops. These loops are came from these loops. So what are the basic loops present in a question? These basic loops are present in a question. So you have to add this all the loops. Then again plus what does I say under the sum of product of two non-touching loops, sum of product of two non-touching loops. So this is two non-touching loops. Is there another two non-touching loops? No. So you have to write only C, B, G. If let's say one more non-touching loops are there, let's say L6 and L7, which are let's say F, G, A. Let us assume if there is one more non-touching loop L6 and L7 which is equal to F, D, A, then here will come sum of non-touching loops, sum of non-touching loops. So you have to add this loop with this loop. So here will come FDA. So like this will come. Okay, when they say there is, when you find one more non-touching loop. Okay, for now there is no non-touching loop. Okay, so only
Sir, L3, L4.
okay, L3, L4. Okay, someone say L3 and L4. EDG, EDG. Okay, listen. EDG. This is one loop. Look at carefully. This point G is touching this loop. ED, G. This and this loops are touching at this point. Carefully look for L2, L4 loop. Look for L2. C, B. None of these points is touching loop G. So that's why there is only one non-touching loop, which is C, B, and G. But in case of ED and G, look at carefully. In case of ED and G, there is a point which is repeating, which is touching. We are touching the two loops. At which point? X4 point. That's why we are not writing non-touching loops EDG under this portion. Okay. I hope you get these two loops are touching at this point.
Got it.
Okay, good. Now this is for the denominator part. Now for the numerator part. For the numerator part, we will go for numerator part. Okay. Okay. Now we will go for numerator part. So first forward part. I will say M1. M1. I will say M1. First forward part. Here also I will say M1, M2. So I have to write first forward path, which is equal to ACE, which is equal to ACE. Wait for a minute. Okay. Wait for okay. First forward. What is the first forward path? A C E. A C E. What is the first forward path? A C E. Now check for the loop. Check for the loop. I have said I have written M1. At the end, I have what I have to I have to write M1 into delta 1. Na? I have to write M1 into delta 1. What does delta means? 1 minus this portion. 1 minus this portion. But you have to take one more step in this. What is the step? Check for the first forward path A C E. Then multiply it with delta 1. Multiply it with delta 1. But delta 1 should be such that none of this loop, you have to write delta 1 for that point. It means that how to say that? Okay, listen. ACE. Check ACE forward path ACE. Okay, this is the first forward path. Now check the loop which are not touching this path. ACE. Check the loop which is not touching this path. Is there any loop? Can anyone say? Can anyone tell me? Is there any loop which is touching this, which is not touching this forward path? ACE. Can anyone tell me? Is there any loop which is not touching ACE forward path?
G loop.
G loop. Okay. Listen. One more time I will say. Okay. Look for G. Look for the first forward path. ACE. What are the points it are in? What are the points is included in first forward path? X1, X2, X3, and X4. Okay. Now you have to check those loop. Which are not, which loops will not include these points. You have to check for the loop which not includes this point. So for the first forward path ACE, it includes X1, X2, X3, and X4. But for G loop, it is X4. So X4 for the G loop, X4 is touching this forward path. G loop is touching this forward path. So that's why there is no as such loop which is not touching forward path. So there is no as such loop which is not touching forward path. यहाँ पे देखिए सब फॉरवर्ड पाथ कौन सा है ACE. इस फॉरवर्ड पाथ में इंक्लूड किए गए पॉइंट कौन से हैं X1, X2, X3 और X4. बट जो G लूप है वो X4 पॉइंट पे टच हो रहा है, इसलिए इस पाथ को टच नहीं होना रे. एक भी ऐसा लूप नहीं है जो इस पाथ को टच नहीं हो रहा. ठीक है. So that's why there is no such loop which is not touching this path. All loops are touching this path. Okay. So here will come delta 1 will come 1. Yes.
Got it, sir.
Okay. Now and check for second forward path. Check for second forward path. What is second forward path? AF. So can anyone tell me AF forward path? Is there any loop which is not touching AF forward path? Is there any loop which is not touching AF forward path? This forward path, is there any loop which is not touching forward AF forward path? Can you tell me, is there any loop?
CB.
Okay, CB. Okay, listen. Now once more. What is our forward path? No loop. Okay. The answer is no loop. So wait for a minute. How I will tell you how there is no loop. Okay. Listen. Forward. What is the forward path? AF. Okay. Look at this loop. ED. ED is touching at this point. So ED will cancel.
Very good.
Next loop CB. CB is touching at this point. So that's why CB loop will also not come under this loop condition. What is our condition? There should be no such loop which should connect the forward path. So ED loop is connected at point this X4. CB is connected at point X2. So that's why there is no such loop which is connected to this forward. So that's why there is no such loop which is not connected to this forward path. Which forward path? AF. All are connected somewhat somewhere. Okay, so that's why M2 will always come. M2 delta 2. M2 delta 2 will come as what is M2? AF. AF into 1. AF into 1. Okay. Okay. Now at the end you have to write a transfer function. So at then I will write as a comma. Okay, I will write here. Transfer function for the system. Transfer function for the system. TF is equal to M1 plus this M1 delta 1 plus M2 delta 2. M1 delta 1 plus M2 delta 2 divided by delta, which will come like ACE plus AF whole divided by delta, which is equal to delta, which is equal to 1 minus FDB plus CB plus ED plus G plus CBG. Okay, this will come. This is not C, this is bracket. Okay, so answer for this signal flow graph is this. Okay, so transfer function for this signal flow graph is given by this one. First of all, what you have to do when you have to find signal flow graph? First of all, write down all the forward paths. Then look for all the loops. Then look for non-touching loop, two non-touching loop. Then look for two non-touching loop. What are the two non-touching loops? L2 and L4. You may also find its probability of getting three non-touching loops are very less in exam, but you may find such loops which there in figures in which there are three non-touching loops. So till now we have get two non-touching loops. What are the two non-touching loops? L2 and L4. Which are they? L2 and L4. Okay. Then what you have to do? Write down the forward path. What are the go for denominator portion. Write the delta 1. Then go for forward path. Then check whether any loop. Which is not touching this forward path. If there is no, put value 1. Then go for another forward path. Then check is there any loop which is not touching that forward path. If there is no such loop which is not touching that forward path, then go then put the value is equal to 1. Okay, that's all. Please write down this question. And answer. Okay. Now next point. I hope everyone written down this or take a screenshot of this question. I will take aside for 1 second. Okay. Okay. Now listen. I will tell you another important portion under this. Which is equal to which is heading is goes like Routh-Harvard's criteria. Routh-Harvard's criteria. Okay, listen. What does I at starting I say 1 plus G of S into H of S is called as characteristics equation. Okay, na? 1 plus G of S, H of S is called as characteristics equation for negative feedback. Okay, please check this. Whenever they say negative, use here positive. Whenever they say positive, use negative. Okay. So this is characteristic equation. This characteristic equation is useful to tell. Whether a system is stable or unstable. Okay. Now what does it mean? Routh-Harvard criteria. So how to find this Routh-Harvard criteria? Okay. First of all, First of all, let's say, okay, listen. Let's say 1 plus or minus g of s h of s is equal to a to the a1 s4 a2 s3 a3 s2 a4 s1 and at the end a5. At the end a5. Let's say you have got the equation like 1 plus or minus g of s h of s is equal to a1. This equation, this characteristic equation you get. And how can you tell whether the system is stable or not? And how can you tell whether the system is stable or not? So there is a method to solve or to tell a system is stable or not. One thing is clear. Whenever pole lies on left hand side, this is left hand side, this is RHS. If poles lies on right hand side of a plate, if poles are lies right hand side of a plate, it is unstable. When pole lies left hand side of a plate, it is called as stable system. So what are the poles? So G of S, H of G. Let's say okay, for a minute transfer function. There is some transfer function which is given by s minus 2 upon s plus 1 whole divided by s plus 3. So what are the poles of a transfer function? So what are the poles? So poles of denominator is called, so roots of denominator is called poles. So poles are minus 1 and minus 3. Zeros. So what are the zeros? Zeros for this transfer function is plus 2. What are the zeros for this transfer function is plus 2. Let's say this kind of transfer function is given to you. So if they ask what are the poles of this transfer function, so you have to write poles. What are the poles? Denominator part minus 1 and minus 3. What are the zeros? You have to write 2. Okay. Now check here. Okay. Yes.
Can you repeat transfer function?
Can you repeat?
Transfer
Okay.
function.
Okay. The transfer function is equal to s minus 2 divided by s plus 1 bracket s plus 3. S minus 2 divided by bracket s plus 1 bracket s plus 3. Okay. So denominator part is called as poles of a transfer function. Numerator part is called as the zeros of a transfer function. So we have to always consider poles of a transfer function for stability. If I want to say whether the system is stable or not, I have to check for only poles. There is no such importance of zeros in transfer function which will tell whether the system is stable or not. But to tell a system which is stable or not, you have to see poles of a transfer function. So how can you tell whether this system is stable or not? See what are the poles of this transfer function? Minus 1 and minus 3. In our normal graph paper, I will write LHS and RHS. For this side there will be negative values. This side there will be a positive values. Okay. This side will be our positive values. So where does this minus 1 and minus 3? I have to write poles. Here are poles. In this axis, I have to write poles. So where these poles lie, minus 1 and minus 3, these poles lie in left hand side of a plane. Let's say minus 1 and minus 3. So in left hand side, system is stable. In left hand side, system is stable. In right hand side, system is unstable. So okay. So if the pole is, if one of the pole is positive, then it will lie at right hand side of the plane. Then it will lies right hand side of the plane. At that moment, whenever a pole lies right hand side of the plane, then the system is unstable. For now, our system is stable. For now, for this question, our system is positive. Okay. You will tell this for whenever the s to the power is 2, when denominator s to the power is 2. But whenever there is such a big equation, whenever there is such big equation finding poles of this equation is made difficult. Finding poles of this equation made difficult. So you have to go with Roth-Harvard criteria. So you have to go with Roth-Harvard criteria. So how does it came? How to solve this? How to solve this? You have to write what is the biggest power. Biggest power in characteristic equation is equal to S4. S4, S3, S2, S1 and S0. Okay. Now you have to write like A1, A2, A3, A4 and A5. So remaining part will be 0. Remaining part will be 0. Now you have to find S2 term. Now you have to find S2 term. So how can you find S2 term? The formula is A2 into A3, A2 into A3 minus A1 into A4 whole divided by A2. Okay, to find this portion, there is a formula which is given by A2 into A3 minus A4 into A1 whole divided by A2. To find this formula, same. To find this portion, you have to multiply this into this minus this into this whole divided by this. Okay, so A4 into A5 minus A3, which is equal to 0 whole divided by A3. What I done? A4 into A5 minus A3 into 0. A3 into 0. What is A3 into 0? 0. So that's why I have not written A3 whole divided by A4. So A4 cancel. So at the end, what will come here? A5. What will come here? A5. Okay, A5. So how to find S1 now? How to find first row of an S1? How to find first row of an S1? So for S1 you have to same calculation. Do this, calculate this. After calculating this, multiply with this into this minus this into this divided by whole this part. Okay. So what you have to do to find S1 first column, first row, first column of S1, what you have to do? First of all, solve this. After solving this, multiply that with A4, subtract it with A2 minus A5 whole divided by this portion. Same for S0. Same for S0. After calculating this table, check. After calculating this table, check for negative sign. Check for negative sign in a column or a row. If there is any negative sign, any negative sign for A1, A2, or this whole portion is negative, or for there here is negative, or any of this row is negative, then your system is unstable. Sorry, column. So there should be no sign change in your first column. Which column? First column. This is your first column. So there should be no sign change. What do you mean by sign change? All are plus. If all are plus, the system is stable. If one of this column is negative, the system is unstable. Let's say 1 plus, let's say here is minus. So plus 2 minus, one sign change, minus 2 plus another sign change. So there are two poles which are lying right hand side of a pole. So there are two poles which are lying right hand side of a pole, and our system is unstable. So you have to check whether in first column there is any sign change or not. Okay. So we will discuss one question. Okay. So question, please note down this. I will write. There should no. There.
Sir, S2 च्या third column आहे ना?
Yes. Please repeat.
S2 च्या third column मध्ये काय येणार?
ether 0. Okay, to find this portion, what you have done to find this portion, a4 into a5 minus 0 into a3 whole divided by a4 you have to done. Okay, now you have to find this portion. Okay, so what you will do, this into this, is there any part? So we'll write as 0. Then minus this into this, is there any part? You have to write 0 divided by this. So at the end what you will get? 0. So at the end what you will get? 0. So there will be no part in S2 third column. So there will be no part for S2 in third column. So how there will be no part for S2 in third column? Say, to find second part, second column, S2 second column, to find S2 second column, what we have done? A4 into A5 minus 0 into A3 divided by A4. Okay, so what will come? A5. Okay, now to find S2 third column, is there any part? Is there any term? Is there any term? No. So that's why there will be no such part in S2 third column. So there will be no such part in S2 third column. So what is necessary condition to check whether a system is stable? So there should no sign change. There should no sign change in first column. Okay, there should no sign change in first column. Okay, now we'll go for an example so you will understand this concept easily. So you will understand this concept easily. Okay. So question goes like, there is system plus minus 10s plus 2, 10s plus 2 whole divided by s into s plus 4, s into s plus 4, s square plus 4s plus 20, s square plus 4s plus 20 tell whether system is stable or not. Can anyone tell me system is stable or not? So you have to find, or you have to tell whether the system is stable or not. But you have to tell whether the system is stable or not. Can anyone tell me? Solve in your notebook. If anyone gets doubt, ask me. I will, or else I will explain how to solve this question. Okay, now listen, I will tell you how to solve this question. First of all, you have to find a characteristic equation. First of all, you have to find characteristic equation. So can anyone tell me what will be the characteristic equation for this question? CE, I will write as CE, characteristic equation. In shortcut, I will write as CE, characteristic equation. Can anyone tell me what will be the characteristic equation for this question? What is the characteristic equation for this question is 1 plus g of s into h of s. Okay, yes. Is there anyone? Okay, listen. Whenever
1
they give,
plus
yes, tell me, yes.
1 plus 10 in bracket s plus 2.
No, you have to simplify that question. You have to simplify that question. Okay, listen, I will tell you what will be the characteristic equation for this question. First of all, always the question will give in exam, always question will give in this form. If there is a question, always they will give in this form. Or else they will say unity feedback, or else they will say unity feedback. Unity feedback. Okay. So listen, is there any part of h of s? Is there any part h of s? No. So you have to take h of s is equal to 1. Okay. H of s is equal to 1. Good. So to find the characteristic equation for the system, you have to do like 1 plus g of s h of s is equal to 0. 1 plus g of s h of s is equal to 0. Now, after doing this, put the values, all the values in this equation. 1 plus negative feedback. Negative feedback, that's why I've taken plus. There is a negative feedback, that's why I've taken plus. So check. This is g of s, whole part is g of s, h of s is equal to 1. So write this 10 s plus 2 whole divided by s plus 4 s square plus 4s plus 20.
सर हे ओपन लूप सिस्टमच आहे ना.
No, this is a closed loop system. Check, na? There is one
HS
feedback.
नव्हतं दिलं.
Yes?
HS नव्हतं दिलं ना पहिल्यांदा.
Okay. Even if they are not given HS, but there is something which is coming from output side of the system and giving input side of the system. If whenever in a graph, whenever in any system, or whenever you say in any kind, not in control system, even in machines, even in power system, anything which we are measuring from output side, which we are measuring from output side and giving to the input side, then this system is called as closed loop system. Even though h of s is equal to 1, then also this system is called as closed loop system. Okay. When is open loop system? When there is no such connection. In this condition, this is the open loop system. In this condition, this is the open loop system. But whenever there is such connection which is coming from output side of the system and giving to the input side, the system is in closed loop system. So that's why this is a closed loop system. Even though h of s is equal to 1, but there is some part which is taken from the output side of the system and giving to the input side. That's why the system is called as closed loop system. Okay, I hope you get this. So after solving this, multiplying whole this term with 1 and then solving this question, you will get characteristic equation as I will directly write the characteristic equation. I will directly write s4 s to the power 4 plus 8s cube plus 36 s square plus 90s plus 20 is equal to 0. Okay, where is the denominator part? Where is it? Listen carefully. Where is the denominator part? What did I do? I multiply this denominator part with 1. So that these two are having a common denominator. After that, I shift this denominator. To this side. So multiplying this denominator with 0, at the end we get 0. So after solving this whole equation, you will get characteristic equation as s4 plus 8s cube plus 36s square plus 90s plus 20 is equal to 0. The characteristic equation for this equation is given by this. Now you have get the characteristic equation. Now draw the Rhodes-Harvard table and tell me whether the system is stable or not. Now tell me whether the system is stable or not. Okay, I will rub this. This take a screenshot or write it, pass down in the notebook. I'm rubbing this and I will tell how to find Rhodes-Harvard table. R is stable. I will short. I will say R is stable for the system. Okay. Okay. I hope everyone written down this. Okay, I will write this characteristic equation aside, a bit of aside. I will write it here. S4 plus S8 S cube plus 36 S square plus 90 S plus 20 is equal to 0. So this is the characteristic equation. So you have to draw a Rhodes-Harvard table. So how does it will came? How do it will look like? It will look like S4, S3, S2, S1, and at the end S0. Okay. Okay. So how to write this? What is the coefficient of S4? 1. And 8, 36, 90, another again 0, 20 and 0. Okay. Now you have to find S2. To find S2 coefficient, what I say to find S2, I will find coefficients here and then I will put it down, write it down here. Okay. So what is S2 coefficient? 8 into 36, 90 whole divided by 8. So what does it came? 24.75. At the end, this will come 24.75, which is positive. So at the end, I will say positive 24.75. What will come here? What will come here? Can anyone tell me what will be the coefficient of S2 second column? Can anyone tell me what will be the coefficient of S2 second column?
-2.
Can anyone tell me? Minus
2.
minus 2. Okay, I will let's check. What I say, what will be the coefficient for S2 second column? So you have to find this part. So to find this part, what I have to do? 90 minus 20, 90 minus 20, sorry, 90 into 20 minus 0 into 36. What will I do? 90 into 20 minus 36 into 0 whole divided by 90. Whole divided by 90. I will do like this. Okay. So at that this portion is equal to 0. So 90 cancel. So at then I will get positive 20. Please cross check your question. Please cross check your answer. They will know as minus 2 such term, there will be a positive 20. There will be a positive 20. Okay. Now I will go fast forward. I will directly say what will become here. Okay. This is positive. 24.75 is multiplied with 90. So the value will be much more higher than compared to this value. Listen carefully what I am saying. This is 24.7. Now I am finding S1 first column. So look at carefully. 24.75 is multiplied with 90. 24.75 multiplied with 90 is very much greater than 20 into 8. So that's why this S1 term first column will always positive. How this will come? You have to multiply this, subtract this. 24.75 multiplying with 90 minus 20 into 80. So this first term is always greater than the second term. First term is always greater than the second term. So that's why this S1 term first column is always positive. So that's why S1 term first column is always positive. Is always positive. What will come here? 20 or 0. What will come here? 20 or 0? 0. Here will come a 0. And at the end solving this, you will get always a positive value. Because this positive is multiplied with 20 minus this into this, which is equal to 0 divided by this positive. So I have not solved a question. You have to solve this question for yourself, but I will pass forward this question and I will say, so check for first column, is there any sign change? For first column, is there any sign change? All are plus, 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 plus. So there is no such kind of sign change. That's why the system is stable. So there is no such kind of sign change in first column. That's why system is stable. So that this kind of question are expected to come in exam. This kind of questions are expected to come in exam. So under this Roth-Harvard criteria, there are many such types, but I will not go in depth of time because of time constraint. So I will go for another points which I think may expected in exams. Okay, there is one such part. There is one also such part. Okay, wait for a minute. Okay, there are two such parts. Okay, there are two such parts. Not two such, but I will say initial value theorem and final value theorems. Initial value theorems and final value, these are two basic and easy parts. So I think I should tell this point to you. Note it down. Initial value theorem. What do you mean by initial value theorem? Which is equal to initial value theorem, which is equal to C of 0 is equal to limit t tends to 0, C of t, which is equal to limit s tends to infinity, s into C of s, This is the initial value theorem. This is initial value theorem. One more, there is final value theorem, which will be C to the infinity bracket is equal to limit t tends to infinity, C of t, which is equal to limit s tends to 0, s into C of s, which is given by s into C of s. So many of the times question is asked like, tell the initial value of a system, tell the final value of a system. So you have to use this formula. So when to use limit C of t tends to infinity, when a transfer function is given in terms of time domain. When transfer function is given in terms of time domain, you have to use t tends to 0 or t tends to infinity. When a transfer function is given in C of s, when transfer function is given in S domain, so you have to use this formula. Please, okay, fine, no problem. So we will see one question. On these two formulas. We will see one question on these two formulas. What do you mean by this C? This is always a output. write in bracket output, only output. It is not transfer function, only output. Output. There is no such input, only output value, only output value. Okay. Please note down. Please note down. I will tell one question. Easy question. You may solve in fraction of seconds. Okay. Okay, check. What is the question? Find initial and final values of a transfer function. Find initial and final values of transfer function for r of s is equal to 1 by s, r of s is equal to 1 by s, and the transfer function is given by c of s whole divided by r of s is equal to c of s divided 10 plus s4, 10 into s plus 4 whole divided by s plus 2 and s plus 5 whole divided by s plus 2 and s plus 5. What is the question? I will repeat one more time. Find initial and final values of transfer function for r of s is equal to 1 by s. Transfer function is given by c of s divided by r of s is equal to 10 s plus 4, s plus 2 and s plus 5. Okay. So can anyone tell me? So can anyone tell me initial values? Okay, listen. If anyone get, please solve. If anyone get, you can unmute and tell me, or else write in the chat box. Even though I will tell you how to solve this question. First of all, initial value and final value theorems are only for C of S or C of T. But our question is in form of C of S divided by R of S. So from this question we can find C of S. What is the value of C of S? C of S is equal to 10 into S plus 4 whole divided by S plus 2 bracket S plus 5 into R of S. So what is the value of R of S? 10 S plus 4 bracket S plus 2 S plus 5 into 1 by S. Question 1, R of S value is given in the question. So this is C of S. Then what? For initial value theorem. I have written initial value theorem in dot v dot t, which is given by limit s tends to infinity s into C of S. So what is C of S? Limit s tends to infinity s into s plus s into 10 s plus 4 whole divided by s plus 2 whole divided by s plus 5 into s and s get cancelled. So you have to put s tends to infinity. So you have to put s to the value infinity. And can anyone tell me what will be the value for this? Okay, listen. Okay, listen. How to explain it? I should explain this. Okay, listen. You have to put what you have to do. You have to put value s is equal to infinity. You have to put value s is equal to infinity. Now see, now see, now see. Whenever something small is added to yes, is there any answer? Okay, now listen. When what you have to do, you have to put s is equal to infinity. So whenever you add something or subtract from the infinity, the value always remains infinity. So whenever you add or subtract or multiply or divide or any operation you do on infinity, any mathematical operation you are doing on infinity, it always remains infinity. It always remains infinity. So comparing to the infinity, this 4, this 2, this 5 terms are negligible. Comparing to the infinity, these 4 to 5 terms are negligible. So we can neglect 4 to 5. So we can neglect 4, 2 and 5. So at then what will come as 10s divided by s square. So s and s get cancelled. Now we have to put 10 divided by infinity, which is equal to 0. Anything upon infinity is equal to 0. Anything upon infinity is equal to 0. So initial value theorem. So the initial value for this transfer function is equal to 0. So the initial value for this transfer function is equal to 0. So what will be the final value? So what will be the final value? What will be the final value? What will be the final? What I have done? Listen carefully. What I have done in this question. You have to put s is equal to infinity. S is equal to infinity. So anything is added to the infinity, s plus 4, which means infinity plus 4, it always remains as infinity. Anything is added to infinity is always infinity. That's why I have neglected 4, 2 and 5. At the end, what will come? 10 s divided by s square. So s and s square get cancelled. So 10 by s. What you have to put s is equal to infinity. So anything by infinity is always equal to 0. So initial value for this transfer function is 0. Initial value for this transfer function is 0. Now I have to find final value. So for the final value, which is equal to limit s tends to 0, c of s into s. So what will come? S into 10 s plus 4 bracket close divided by s plus 2 s plus 5 into 1 by s. So this s get cancelled. So you have to put s is equal to 0. So the putting directly s is equal to 0. So putting directly s is equal to 0. At the end you will get answer 4. At the end you will get answer 4. What I did in this formula, I write a formula for CS. I have put the value of CS, put the equation of CS. What is the equation of CS? 10s plus 4 divided by s plus 2 s plus 5 into s. This s and this s get cancelled. Putting s value is equal to 0. At the end, you will get a final value is equal to 4. So for the system, initial value will be 0 and the final value will be 4. Initial value is equal to 0 and final value will be 4. Okay. I hope everyone get this point. One more thing, everyone notice that. Please. One more thing, everyone please note down. Okay, I will. Okay, I will tell you. Okay, in transfer function, look at this transfer function. Question were asked in exam. Look at this. Question were asked in question is such like that they say and I think in 2009 or something 2010 the question was come in a GATE exam. It was just framed by IIT Delhi, I think IIT Delhi. Question was like 10 s plus 4, s plus 2, and s plus 5. Same, not exactly the same question, but what they ask in the question: find final value of this transfer function. Find final value of this transfer function. Okay, I got this question. What is the final value of this question is 4, but they have made a small change. But they have made a small change. What they did instead of this plus they put negative sign. Instead of this plus they have put a negative sign, and that then after that they ask same question. Then they ask find final value of this transfer function. So before finding any final value of a transfer function, before finding any of the final values for this transfer function, first of all check whether system is stable or not. So because of this minus 2, poles of an equation are poles poles of an equation are, what are the poles of this equation? Plus 2 and minus 5, plus 2 and minus 5, plus 2. So where does this plus 2 lies? Here. Where does this minus 5 lies? At left hand side. So this was very tricky question asked in a GATE exam. Not exactly the same question, but they said find the final value of a transfer function, and they give one of the pole which lies right hand side of the plane, So if any of the pole which is like right hand side of the plane, what does it mean? It means that a system is unstable. So the system is unstable. So that what does it mean? What does it? It means that system will never be stable. System will never be stable. It means that system will never give a constant value at output side. A system will never give a constant value at output side. So many of the many of the students get tricked by this question and choose a wrong answer So always remember, before finding initial and final values, of a system, first of all check whether system is stable or not. In our case, in first question system was always stable. That's why I find initial and final values of a question. But a bit of change, a small change I have made in a transfer function, but that small change affect the whole final value. How it affect the whole final value? Because of the small change, the whole transfer function goes into unstable form, and that's why we cannot get a final value for the system. Okay, I hope everyone got this point. So one more important
Sir, then
formula.
when it is
Yes.
unstable, then we have to. Hello.
Yes, I'm listening. Please. Hello. Is my
Sir,
voice?
if there is,
Yes.
if it is unstable, then we did not. Hello.
Hello, I'm listening, but your voice is breaking. Yes, I'm getting your voice, but it's fake.
We did
Is
not
there
need to solve.
No. Okay. Always remember, GATE exam faculties which are framing questions for GATE exam. What will they do? They will give same this question. Let us assume they will give the same question. What will they do? They will say find final values of a transfer function. What they will say, find final values of a transfer function, and you will find final value of a transfer function. But by mistakenly, you did not see whether the system is stable or not. by mistakenly you did not see whether the system is stable or not, you directly solve and find the value of final value of the system, and you will get answer 4. The option 4 will be in the option. Option 4 will be definitely in the option, and one more option will be there. One more option will be there. One more option, which is like unstable. A system is unstable or zero. A system is unstable or zero or anything infinity. 3 of the one option will be definitely there. One is 4. One will be another value 3. One will be another value 5, and one more option will be a system is unstable. So they will not frame a wrong question, but instead of that, they will definitely give an option. They will definitely give an option whether a system is unstable or not. So even though this question is not wrong, this question is not wrong, but this question is tricky question, and this answer for this question is an answer for this question which I can a bit change is that a system is unstable. That's why final value will not be determined. Final value will not be determined. This kind of option, I'm not exactly knowing what option is for that type of question, but there will be definitely one option which will give an information about the system. 3 option will be like 4, 3, 2, but the 4th option will be like a system is unstable, or system is stable, or system is something other example. Okay, not like the other options. Okay, so the answer for this particular this question, when I change plus from minus, answer for this system is can't be determined, or system is unstable. Can't be determined or system is unstable. Answer for this question. Okay, answer for this question. Okay, there are some important formulas. There are some important formulas. Under second order response, under second order system. Wait for a second. Okay, there are some important formulas. So I will give me this. Okay, I will tell you some important formulas which may expected in exam. Which are what are the formulas? It comes under the heading. It comes under standard second order system. Standard second order system. Standard second order system. Whatever the formula I'm telling, all this formula comes under standard second order system. This is the heading which comes under this. Okay. The first formula is for damping coefficient. First formula is for damping coefficient, which is given by alpha, which is given by alpha, which is equal to zeta. Okay, there. Before that, I have to tell you what is second order system. Second order system is given by transfer function for second order system. Transfer function for second order system is given by omega n square whole divided by omega n square whole divided by s square plus omega n zeta s plus omega n square. So transfer function for second order system is given by omega n square whole divided by s square plus omega n zeta s plus omega n square. Why it is called second order system? Because order of a characteristic equation. This is the characteristic equation. Okay, this is the characteristic equation CE. This is the characteristic equation, and order of the characteristic equation is given by 2. Order of our characteristic equation is 2. That's why this is a second order characteristic equation. So there are some observation or there are some formulas under characteristic equation. It's called as first formula is damping coefficient. Damping coefficient, which is given by alpha is equal to zeta omega n. Damping coefficient is given by zeta omega n. Okay. There is one more formula, damping frequency, which is given by omega d, which is equal to omega n under root 1 minus zeta square. Okay, this is one more formula for omega d, damping frequency. This is called as damping frequency. Time constant. This is 2. I will give another 3. Time constant. Time constant is given by 1 upon alpha, which is equal to 1 upon zeta omega n, which is equal to 1 upon zeta omega n. Few more formulas. I will tell you. Wait for a second. Okay. Please note down these formulas. Please note down these formulas. Wait for a minute. Okay. Now there are more 2 to 3 formulas. It is impossible to teach about it in 2 to 3 lecture, 2 to 3 hours. But I will tell you what are the important topics you have to do. Okay, what are the important formula? Actual in exam they ask. Okay. Let's say this is the system. This is the output. C of S is called the output, and I will say this is a time. What is it? This is time. As time increases, how should be our response? Our response should be from this oscillating and should at the end it should be stable. Starting it should be some oscillation and at the end it should be stable. Our response is like this. So what is this point? This point is called MP, maximum peak point. Okay. What does this mean? Delay time, TD. What does this mean? Peak time, TP. And what does this mean? TR, rise time. Okay. And at the end when the system is settling down, it's called TS. So there are formulas for TD, TR, TP, TS and MP. I will write down all these formulas. In this side and tell you. Okay, so write down the formula for TD. Write down the formula for TD. D. TD is equal to 1 plus 0.7 zeta by omega n. 1 plus 0.7 zeta omega n. What do you mean by omega n? What do you mean by omega n? Omega n is the natural frequency. Natural frequency. Natural frequency. What do you mean by omega n? Natural frequency. What do you mean by TR? TR. Formula for TR. Formula for TR is given by pi minus phi whole divided by omega d. Pi minus phi whole divided by omega d. And this is in radians. And this is in radians. Remember, this is in radians. This is in radians. So how to find phi? How to find phi? There is one more formula to find phi, which is given by. Have to wait for a minute. Where is the formula? Okay, I got it. Okay, to find phi is equal to sine inverse under root 1 minus zeta square. Sine inverse 1 minus zeta square. This is the formula to find phi. Formula for omega d I have given. To you at the starting. Then there is a formula. For TP. Then there is a formula for TP which is given by TP is equal to pi by omega d. TP is equal to pi by omega d. Then another formula, settling time. Then there is another formula for TS. Okay, names of this I have not given the name. What do you mean by TD? TD is called delay time. Delay time. TR means rise time. Okay. TP means peak time. Okay. Formula for MP. There is one more formula for MP. I will write down. Okay, I will write down here. Formula for MP. MP is given by e to the power. MP is given by e to the power minus zeta pi whole divided by under root 1 minus zeta square. Okay, this is the formula for MP. What do you mean by MP? Maximum overshoot. Maximum overshoot. Formula for MP. Okay. Formula for MP. How to calculate TS? TS is equal to 1 by alpha. If they ask find settling time for 0.5 tolerance. So TS will be given as 3 alpha for plus or minus 5%. TS tolerance. This is given as tolerance. TS is equal to 4 by alpha for plus or minus 2% tolerance. What is plus or minus 2% or 5%? This is called as tolerance. So listen carefully. So how to use this formula in exam? Suppose they have given a second order. Give you a second order transfer function. Okay, I have to take one question so that you can get what I have to say. Okay, listen. Instead of question, I will say Okay, so when to use this formula? So when to use this formula? Whenever they give standard second order system, whenever they use standard second order system, let's say how. Mm, I will tell you an example how standard second order system they will give. So let's say transfer function. They have given an equation 100 divided by s square plus 10 into s square plus mm, 50 10 s square plus 50s plus 100 10s. Let's say they have given a standard second order system which is equal to transfer function is equal to 100 divided by s square plus 50s plus 100 50s plus 100. So what will be the value? So what will be the value of omega from this equation? Comparing this equation, compare this transfer function with standard second order system. Compare this transfer function with standard second order system. You will get values of omega, zeta, and omega n. Values of omega, zeta, omega n. So comparing this equation with standard second order system, you will get omega n is equal to 10 because omega square is equal to 100. So omega n is equal to 10. Can anyone tell me zeta value? Can anyone tell me zeta value? Can anyone tell me zeta value? What will be the zeta value? See, 2 zeta omega n is equal to 50. So you have to compare. So you have to compare this transfer function with standard second order system transfer function. I have given a standard second order transfer function. So you have to compare this value with that function, that transfer function. So you will get 2 zeta omega. And what is the value of zeta? Will be then omega is equal to 10 and 10 into 2 20 5 2.5. What is the value of zeta is equal to 2.5. Okay, you have get the value of omega n is equal to 10. You have get the value of zeta is equal to 2.5. You can find TD, you can find TR, you can find TP, you can find maximum peak overshoot. You can find maximum peak overshoot. Okay. So this so this is the method. So this is the method to use this transfer function in second order system. Okay, so some of the questions are expected from this topic, and there are lots of topics under the system, but because of time constraint, we cannot explain. I cannot teach you, but this is one of the most important topics. So in control system, there are some topics which are related to error analysis, type of the system, order of the system. In control system, you have learned in your graduation level about the topic is called as root locus topic, or the topic is or Bode plot topic or Nyquist plot. So some of the questions were also expected from that topic, but because that topic is very lengthy, we cannot teach you in 2 to 3 hours. But these are some basic questions which may ask. I have not taken an example on this topic, but I have tell how the question will examiner frame. They will give a transfer function, standard second order transfer function, and they will tell you to find maximum MT of this transfer function. So how you can find? You can compare this equation with standard second order system and find values of omega and zeta. Put the values of omega and zeta. You can find all other values. Okay. These are some important topics under control system, where there are a lot more topics, and the weightage for control system is usually between 7 to 10 marks. Weightage for control system is usually between 7 to 10 marks, and the questions are always direct. And the question will they ask direct questions. They will not frame some tricky question on control system. On which parts they will frame a tricky question, on which subject they will frame a tricky question is machines, power electronics, and measurement. In these 2 to 3 subjects, they will frame a very tricky question. But in maths, but in aptitude, but in control system, but in signal system, they will frame a direct question. They will always frame a direct question. They will not use a trick part, because these are very vast topics. These are very vast syllabus, and this is not our basic base of an electrical engineer. Our basic subject, our core subject are machines, power electronics, measurement. These are our base, our power system. These four are our core subject. But the control system, signal system, analog electronics, digital electronics are not our core subject. So that's why they will not frame a very hard or a very difficult question on this control system topics. So if anyone had a doubt, you can ask me anything regarding exam, regarding this today's topic. I will happy to tell you, or I will happy to clear your doubts if anyone has a doubt. One more thing, I have pasted okay. I have pasted a link. I request all of you. I request all of you to please fill that feedback form. I request all of you to please fill that feedback form. Uh, I have request. I pasted in your chat box. I request all of you to please fill that feedback form. And if anyone has a question or anyone has a doubt, you can raise. I will be happy to help you. Sir, Deepak sir.
Yes, Mayur.
Sir, I conclude for today's session.
Yes,
So,
yes. Students, just fill the feedback form. Omkar, Aditi, Manisha, Gaurav, Yash, and Snehal.
so should I end the meeting or wait for me?
Yes, Mayur. Yes, yes.
Okay. Okay. Thank you, everyone.
Just Mayur, if you are having the notes of these whatever you taught,
Yes, sir.
you can share with me also so that I
Yes,
can
sir.
send them.
Okay, sir. I will definitely share
Short
with you.
notes.
Yes, sir. Short notes. Okay.
Yes, yes. Fine. Thank you.
Thank you, sir.